Static electricity in the human body can reach thousands or even tens of thousands of volts. Such high voltage can easily damage electronic chips. But in reality, even with lots of static electricity, electronics are usually fine. Why is that? Because the outer shell of electronics provides good protection. Static may hit the case but won't reach the circuit board. But don't forget, modern devices have many ports, like power, USB, and HDMI. These ports connect directly to the circuit board. If we often plug and unplug cables, the inside becomes vulnerable. So how do we prevent static? Take the power port as an example to prevent static. Almost all circuits have a TVS diode at the input. TVS stands for transient voltage suppressor. Its main job is to suppress voltage spikes. For example, if our working voltage is 5 volts, but a 2,000V spike hits without a TVS, this spike could damage the circuit. With a TVS, the voltage waveform looks like this instead. The TVS clamps the spike to 10 volts, protecting the circuit behind it. When normal 5 volts passes, the TVS has very high impedance, up to megaohms. So the TVS acts like an open circuit. But when a spike comes, its impedance drops below 0.5 ohms. The spike energy flows through the TVS to ground, like a short circuit. Now let's talk about some key TVS parameters. This is its IV curve. When forward biased, it acts like a normal diode. But a TVS works under reverse voltage. This part of the curve, there are a few key parameters here. When reverse voltage is applied, up to Vrm, the current I is tiny. Vrm is the maximum working voltage. I is the leakage current. The device's working voltage must be lower than Vrm. Because under Vrm, leakage is very small. If voltage goes above Vrm, leakage rises sharply. Too much leakage means more power loss, so the working voltage must be below Vrm. When voltage rises to VBR, the TVS breaks down. So VBR is also called breakdown voltage. After that, current rises rapidly but voltage rises slowly until VC. VC is the clamping voltage. Here it's 11 volts. For example, a spike comes in the TVS clamps it to 11 volts. That's what VC does. The device's maximum working voltage must be higher than VC. Because VC may appear at any time if the device's max voltage is lower. It may get damaged. The max current at VC is called IP. The peak pulse current, it means when clamped. This is the max current the TVS can handle. For this one, IP is 120A. If the current goes over, the TVS may fail. VC times IP gives the peak pulse power PPP. When choosing a TVS, if static energy could reach 1 kilowatt, the TVS's power must be higher than that, or it may fail. That's the TVS's function. Did you get it? If yes, don't forget to give me a like.